Good morning, guys. Welcome back to my YouTube channel. This is Yabulela Makau. Alright, this is the population problem. I will be fast, but I'll make sure that you understand what I did from here up to here. Now, the population of a certain community is known to increase at a rate that is proportional to the number of people present at any time. Now, if the population had doubled in 5 years, how long will it take to be tripled? Okay, we all know that our population is doubled for 5 years, but we don't know what happened after it had been tripled for a certain time. Now, don't worry about P naught. Our P naught will be our initial value this time. It's like P at a certain time. Now, our P naught is P at 0. 0 time, we have our population at P naught. This is our initial value actually. Now, what is going to happen? The rate that is proportional to the number of people is this one. dP over dt is equal to kp, meaning that the derivative of population with respect to time is equal to some constant multiplied by the population. Okay? Now, what is going to happen? You're going to separate your variables. After separating your variables, you're going to integrate. Now, here what I did separate my variables. My p now, you're going to divide both sides by p, and then even this side you're going to divide both sides by p. Then therefore p will cancel p, you are left with p. And therefore multiply throughout by dt, and therefore you will be left by k dt. Now, up to here. From here, this is the integration. We all know that 1 over x, the integral of 1 over x with respect to x is the same as ln x. That is the integral of 1 over x from our integration. Now, this is what is going to happen. The integral of 1 over p with respect to p will be ln p. This is equal to the integration of our constant. The integration of our constant is k multiplied by t, because we are integrating with respect to t. We are trying to know the years. And then therefore plus some constant, c. Now, here, what just happened, we all know that our ln p, we're not interested in our ln p, but we're interested in our p. Then therefore for us to get our p, this is going to be e to the power ln p is equal to e to the power kt plus c. Now, from our knowledge of logarithms, the laws of logarithms, it says e to the power ln of something, maybe e to the power ln of x will be equal to x. That is the law of logarithms. This is what just happened here. Ln p, e to the power ln p will be the same as p. Then therefore, e to the power kt plus c. Now, here, from the laws of exponents, multiplying the powers of the same base, you simply add the indices. This is what just happened here. Now, this will be e to the power kt multiplied by e to the power c. Now, note, e to the power c is a constant. And if this is a constant, we're going to treat this one as our initial value. Our initial value is P naught or P at 0. This is going to be P naught or P at 0. And then therefore, our P naught now will be equal to e to the power c. Do you have a question? You can ask.
Why do we have to do that? Oh, by people. You're making...
Okay, this PO. All right. From our statement, it says that if the population had doubled in 5 years, if the population had doubled in 5 years, this is the given information from our statement. We all know that in 5 years, our population will be doubled. But not just our population, the initial value of our population will be doubled. Meaning our P naught. Initially, this will be doubled for 5 years. Now, this is what is going to happen. For 5 years, for 5 years, 2 times the initial value will be equal to the initial value multiplied by e to the power 5 instead of t now. 5. What we are trying to know now, we are trying to know how much is our constant, right? Because it says the population of a certain community is known to increase at a rate that is proportional. We are trying to know this guy, the population constant, which is k. All right, now this is what is going to happen. We are trying to solve for k now. You divide both sides by P naught. P naught will cancel P naught and P naught will cancel P naught. You're left with 2. And then therefore, after you're left with 2, this side will be equal to ln of e to the power 5k. Now, we're not trying to know e to the power 5k, but we want k. For us to get rid of this e, and we bring down the exponent, we're going to introduce the natural logarithm. Ln of 2 will be equal to ln of e to the power 5k. Now what is going to happen is that ln of 2 will come here, and this side, from the laws of logarithms, ln of e to the power maybe x. Let's say x. Then therefore, our laws of logarithms, we are allowed now to take x down. Ln e. And then therefore remember that ln e is equivalent to 1. That is our ln e. Now, this will be 5k multiplied by ln e, which is the same as 1. Now, our ln 2 will be the same as 5k. Now, what is our 5k? Guess what? This will be 0.1386. That is our proportionality constant. Alright. Now, what we're trying to know? We're trying to know what happened after the population is tripled. How long? We are trying to answer the question now. It says if the population had doubled in 5 years. Now, how long will it take to be tripled? Alright, this is what is going to happen now. 3 times the initial value is equal to the initial value of the population multiplied by e to the power of the population constant multiplied by time. Alright, we're trying to know time now. And then therefore, this is algebra. This step is the same as this step. You divide both sides by the initial population, then therefore you will get 3. 3 will be equal to e to the power 0.